Keep your eye on it. Recording or not? So this is class 6. It's class 6. So in the class 6, we will be discussing communication protocols in IoT, which is a part of a physical design. Which is part of a physical design. Here we will be seeing OSI model, OSI reference model, OSI reference model. First we will see this reference model is, what is the meaning of this reference? Total it is conceptual. It is conceptual model. In practical we will be using, basically in practical, in today's world we are using TCP IP as protocol suite. What we might say protocol suite. Why suite? Because it is a set of protocols. Set of protocols. We will see. Let us see OSI. This has 7 layers. This has 7 layers. See, some people say, okay, I will complete. So, how to do it? Okay, so first layer we call it as application layer. Application layer. Second one is the presentation layer. Third one is the session layer. Transport layer. Then we have network layer. Then we have data link layer. The last one is the physical layer. The communication network, you already have seen it. These are the 7 layers. In each layer we have protocols. In each layer we have protocols. So what happens? We will be seeing the functionalities at each layer and the example protocols. These 3 are software layers. These 3 are hardware layers. This will be called as a core layer. These are implemented when writing a software program. These are the hardwares. Middleware, hardwire program. What we call it is a firmware. Hardwire programs. We will see the functionality of each layer. Then protocol examples. What is the function of each layer? See, when it is transmitter, the data flows like this. our message, something is added to our message. What are we add? What are the modifications that we do? You will see layer by layer. So what happens at the application layer? First you will see. Like that, here we will see the functions. Here we will see the protocols. What are the protocols at layer? Here, the message that you write, MESSAG message. Any message you write, right? It is, what is its function? Providing user interface. Using interface. The moment you open the laptop and try to connect it to the network, you open the browser. That is the user interface. You are using the application layer. You are using the application layer, right? So you will be using here network applications. Network applications, right? Like web browser. Web browser. And you will be writing some message. You will be writing some message or some data, whatever it is. Then this message comes to this layer, presentation layer. When your message comes to this presentation layer, I will time as MSG just update message. What are the functions that here takes place? Here translation takes place. Translation takes place. Means it is converted into binary in ASCII format. Compression takes place. Encryption, decryption, all those processes take place. To your message, all these functions will be done. Then it will next pass on to the session layer. Your same message will pass on to the session layer. In your session layer, what are the functions that take place? Connection. In connection, like what? Create the connection, manage the connection, then after that, end the connection. That is what we call it as a session management. Session management. For example, you want to access any banking service. You type username, you type password, session established. Then you do your all those transactions. Right. So other than that, what happens? Authorization. Authentication. That is the last one. Username, password. Then authorization. Permitted to use the data. Are you permitted to use the data or not? For example, you access the RGKD website. You are able to access your own data, not other students' data. You are able to see your own results, your own attendance. So all those things here happens. Now, when this comes to the transfer flow, it is broken into segments. So on. It is broken down into the segments for transmission. See, for example, if you transmit the one message at once, if it is lost, it is lost. Yes or no? Now, if you transmit, if you segment it, if you make it into pieces, and if you transmit it, one of right segments also lost, no problem. Clear? Now here in transport layer we refer these as segments. We refer these as segments. Right. So in transport layer we also add port number. For example, HTTP has different port number, HTTPS has different port number. Right. See, your system will have a IP address. Yes, now you are using a computer, your computer has a IP address. You open it, communication is happening. Now, if you open multiple tabs and you use multiple applications, so for those things, how will like which tab you are referring? Whenever the transmitter is sending the data and you are receiving the data. To which tab it has to send the data? To which tab it has to send the receive the data? He is sending and you are receiving. You have opened the multiple tabs. To which tab? One tab is WhatsApp. One tab you are using YouTube. In one tab you are using email. So when the message comes to your system, yes, it comes right by referring to your IP address. Yeah, it came. But to which application the message has to go? That will be decided by the port address or port number. That will be decided by the port number. Right. So now here, what happens here? What is the function in the transport layer? Breaks into segments. Breaks into segments. And this is service to service delivery. Service to service delivery. I said an example right now. You have opened a WhatsApp tab. You have opened a YouTube tab. Whenever the information comes, whenever the message comes, it has to go to the WhatsApp tab or YouTube tab. That will be decided by the port number. So it is service to service delivery. Go. Understood the idea of service to service delivery? Clear? Right. So here, addressing scheme is here we have ports. Here, two types of protocol we use: TCP and UDP. Two types of protocols we use: transmission control protocol and user datagram protocol. So transmission control protocol, it is connection oriented, it is reliable protocol. Whereas UDP is efficient protocol. There are certain other characteristics to TCP and UDP. Look at it. It is not required to get that much deeper at this point of time. Right. There are few characteristics of TCP. There are few characteristics of UDP. Right. So TCP is reliable. UDP is efficient. It doesn't mean that TCP is better. It is not like that. It depends upon your application. TCP is reliable but consumes more resources. That you should remember. It consumes more resources. UDP, it is efficient, means it consumes less resources. Less resources, but not reliable. It doesn't mean that it is not good. Depending upon the application, you have to choose. For example, a WhatsApp message. When you type a WhatsApp message, the message exactly you have typed should be received. There should even one character should not miss there. Then I will go for which one? TCP. I will go for TCP. WhatsApp call. If there is 1 minute, 2 seconds, if something is missing, no problem. Yes or no? In WhatsApp call, you are watching a YouTube video. Now you prefer UDP. Some fraction of second, some segment is missing, no problem. Are you getting me? So these are the examples. So we have port addresses for TCP also. For TCP also we have port addresses from 0 to 65, 535. For UDP also we have port addresses from 0 to 65, 530. These many ports we can have. Next. Now what happens next? This message, a segment, for each segments, what happens in the, here we have added the port numbers. Now here in the network layer, once it comes to the network layer, what we will have to each message, I will have IP address of source, I will add IP address of destination. Right. So along with port number. Right. So port means PN means you should remember. PN means port number. These are logical ports. Don't think that these are physical ports. Like your USB port, Ethernet port. It is not like that. These are logical ports. So here, once IP address of source, IP address of destination is added. So here I will call it as a packet. Here I will call it as a packet. We should remember this terminology. At watch layers, what your message is called as. After adding the source IP address, destination IP address, which are we are going to call it as a packet. So this is what I am using. It is your IP address is the logical address. Your IP address is the logical address. And here service to service delivery. It is end to end delivery. From transmitter to receiver to your device, not to your service. Just now I given the example for service to service. Clear? So IP, the present we are using is IP version 4. IP version 4. At present we are using IP version 4. Yes or no? Yes, so it is a 32-bit format. It is a 32-bit format. So 32-bit, that is 8-bit, 8. That is each is of from 0 to 250. When you convert in decimal 0 to 250. So how many unique addresses I will get by this string? 2 raised to 32. 2 raised to 32 unique address. And these many devices. Because you know in IoT you need to have unique address either in IoT or in TCP. Over the internet we need to have a unique address. So how many unique address or how many devices I can address? 2 raised to 32. So what is 2 raised to 32? Is there any calculation you have? Number? You will have a number here, let me check. Huh? Right, no. Approximately 4 billion. Yes, very good. Approximately 4 billion devices. What is our population on this earth now? 8 billion. If each one is using one device, if each one has a mobile, so imagine, are these 4 billion enough? No. So in IoT, so we have developed a new version called as IP version. It is 128 bits. 128 bits. This 2 raised to 128. These many devices is a touch. Right. Did I have it? Means 3.4 into 10 raised to 38 addresses cycle now. IP version 6. These many addresses I can have. So how is this format? It is 128 bit. So here we have hexadecimal number of 8 groups. Hexadecimal of 8 groups of 4 hexa numbers. 8 group of 4 hexa numbers. Each hexa number is a 4 binary bit, 4 bit. Each hexa is a right. So when I say 8 of 4, 8 groups of 4 hexa. This total 32 hexa numbers. Total 32 hexa numbers. 32. Each hexa number is represented by 4 bits. Each hexa number is represented by 4 bits. 32 into 4 is 64, 128. Right. Now in IoT we have another protocol at this layer. Right. The name of that is 6 low PAN. 6 means it is using IPv6. What does the 6 represent here? It is using IP version 6, Internet Protocol version 6. Yellow represents low power. Low power. W means wireless. PAN means personal area network. Right, low power. So one thing you should keep in mind here is in IoT devices they work in constrained environment. IoT devices work in constrained environment. Constrained means yes. Louder, madam. Conditions. Constrained. Resources are less. Very good. Abdul gave the right answer. Resources are less. Less resources. What are the resources that are available? Processing super. Memory will be less. ROM will be less. Processing power is less. Bandwidth is less. Finally, the battery backup will also be less. So I prefer low power protocols. Low power protocols. See, for example, forest fire detection system. Forest fire detection system. Remote in the forest. I have to detect the fire. This forest is spread across 1,000 acres. 1,000 acres. To detect the fire in the forest, one sensor is not enough. One sensor node is not enough. Shiva, wake up. Sit. Step. Is it one sensor enough? 1000 thus forest is spread across 1000 acres. At one corner, at one place, if I keep a sensor. At this corner, I have kept a sensor. On the opposite side of the forest, the fire has occurred. Will this detect it? No. I need thousands of sensor nodes. For those thousands of sensor nodes, do I need to keep on connecting with wires for power supply? It is impossible. It is another headache. Some animal comes will break the wire due to some natural reasons. The wires will break. It is not possible. So they have to run wireless. All the sensor nodes should communicate with the gateway, a controller node or a coordinator node, wireless. When there is no wire, what should we have? Battery backup. Battery backup. And the nodes should be as small as possible. The nodes should be as small as possible. No that like sir I will give 12 volt lithium ion battery or right. No. You can see this buttons I see in the watches. Such battery you have to use for backup and they have to run for years. There is no recovery. If they are lost. If they are not working. No recovery. Come replace the battery. Nothing like that. They will have a life of 3-4 years. They stop working. Forget it. Place other sensors. Throw randomly from the air. Is this clear? Right. So here this is clear and right. So 6 low pan. So 6 low pan. What are another characteristics of 6 low pan? It has a frequency of frequency of 2.4 gigahertz and bit rate of 250 kbps kilobits per second. Low power, low processing. Low power, low processing. Low processing speed. Clear? All those things are covering? Then after this, we pass, it goes to next layer. It goes to next layer. In the next layer, to save this IP message, what I am adding? I am adding the MAC address. What I am calling PA, physical address, or what shall I refer? I shall refer it as a MAC address. Source MAC address, destination MAC address. Here, what is the name? Frames. Here we call them as a. Now we call them as a frames. At transport layer segments, at network layer packet, and at data link layer, once MAC address is added, we are going to call it as a frames. Right. So here we have at network layer, here is frames. We have physical address. What is the address is in here? Physical address. That we also call it as a MAC address. Here we will have a network interface call, or we call it as a LAN call. There is separate LAN card for every device. They should have it. And physical address is a permanent address. Yes or no? Already you know. IP address will keep on changing dynamic, but physical address is a permanent. That is a hardware address. Your mobile should have, whichever is connected to the internet, they should have the physical address. They should have the network interface card. Right. So at network layer, when we forward, we are using the technology is router. The technology that we are using is router. So here we have switch, bridges. The technology that we have here is switches and bridges. Am I correct, Abdul? So how is the MAC address looks? Let us have MAC address is 12 hex numbers, which is equal to 48 bits. Right. Now done. Once it is done, press. It is comes here. Right. So here it is converted into voltages and electromagnetic radiations, radio waves. If it is wireless, so what it is decided here at this place? Here it is voltages or radio. Radio is radio waves. So generally, what is decided here? Here it is decided. Your communication model is decided. Communication mode is decided. Communication mode is decided. It is what? Is it simplex? Is it half duplex? Is it full duplex? That is there. That will be decided. Then it will be decided medium. That is wire or wireless. Wire or wireless. Wire is it your Ethernet cable or is it your OFC? Here if it is wireless, it will be deciding is it your Wi-Fi, is it your 4G, that is 5G or cellular. Here topology is also decided. Topology is also decided. Is it your ring topology, bus topology, star topology? Like that, all those things, physical things will be decided here. How your data or message moves physically over the network. All these will be decided at this layer. When it is receiver, your message will flow like this, in this direction. Somebody say application layer is the first layer and somebody say physical layer is the first layer. It is a convention. At the first, if you are a transmitter, your message goes first to the application layer. User interface. The moment you open the browser, you are using the application layer. And the data moves from top to the bottom. When you are at the receiver end, your first layer, the message that access your layer is, first layer is the physical layer. All those things happens vice versa. Right. Now let us see some application layer protocols. Right. Here in application layer, if you are using the web browser, you are using HTTP or HTTPS protocol. you are using the email app, if you are using the email app, you are using simple wave transfer protocol. Now if you want to transmit a file, you will be using file transfer protocol. Right. So here, one of the protocol example is the encryption and decryption will be done secure socket layer protocol. What the calculation? Yes, sir. Here it will be decided. Here in this layer, it will be decided your file is .mp3 file, is your .jpeg file, is your .pdf file. Then during the receiver side, when these moves up, you will decide which application to open with. If it is .mp3 file, you will open with mp3 player. If it is .pdf file, you will the application in application layer, you will be open with Adobe application. Clear? Now here one example is at the session layer. One example is remote procedure call, session control protocol, remote procedure call protocol, or session control protocols. So these are the some protocol examples at various layers. So how the data flows you have understood across the networks from your device to the device. This you should keep in mind practically. Right. So as a computer science student, you already know this. No. In TCP/IP model, these together is called as application layer. Application layer. Which you are going to find as TCP/IP protocol. Clear? The functions happens sometimes not in a order. For example, first you go for session establishment, login, user, password, authorization and authentication. Later you transmit the data, files. So together in that we are going to call it as a application layers in TCP/IP. It is a practical model that we are using today for internet. So in the second phase we will see some of these generally below up to transport layer. For Internet of Things, we are using almost all same protocols, same technologies. But for Internet of Things, we have some special protocols in the application layer. There are some special protocols in the application layer. What are those protocols? We will see. Somebody let me know. Where is Vikram today? Again option. Attendance sheet from girls started or not? See, boys, they know their purpose in the class. So automatically it is entered. So, our heading is application layer protocols used in IoT. The first thing we should keep in mind is constrained environment. Constrained environment. Note, it is note. Not important, not less important, not more important. So it is 100 rupee note. Make it as 100 rupee note. Constrained environment is low processing speed, low processing rate, speed, however you call technically, low bandwidth, that is of network, less memory, that is RAM, ROM, low battery backup, and technically power. This is a meaning of constrained environment. Environment means what? Parisar. Parisar means what? Surroundings. So, for IoT we are keeping in mind the application layer protocols in IoT. The main idea, the core idea is constrained environment. Whenever they are designing or developing the IoT application layer protocols, they kept this in mind. Constrained environment thing in the mind. Right. So first one is HTTP. Yes, this protocol they are also using in IoT. No. HTTP. What are the few characteristics? It is foundation of www, World Wide Web, information web. Again, we have already seen in users commands. In communication models, we have seen users commands like get, put, post, delete. We already seen. It is based on request, response, communication model. Right. So request, response. When client sends the request, server response, how they communicate, they will use all these commands to communicate. They will all these commands. Right. So it is stateless means request commands are independent. You are every time you are a new person to the server. You ask something, some information, your result. After 5 minutes, again you are asking your attendance. You are a new person. There won't be any transmitter receiver information stored there. But whereas in case of your publish this one exclusive pair, they will store the information. Who are you calling? Who is on the line? Till the connection ends. Who is on the line? Who is speaking? Right. So transmitter receiver information is available throughout the call. But here it is stateless. All the commands are independent. Right. When compared to the previous. This uses URIs, Universal Resource Identifiers, right, to identify resources. Just now I discussed slash. Oh, in the other class I have discussed. For example, you want to access the result www.rgpt.e4/csc/result. This is universal resource identifier. There is a little difference between locator and identifier. Technically, we should be perfect, but at this point of time, just keep this in mind. Right. Example: browser is a client. Which is on the IoT device. Server. Any website. Then we have new protocol. This is new in the sense with respect to IoT. The name itself is the second type of application layer protocol that we use in IoT is COAP. First point, constraint area protocol. First point itself, full form. The word constraint. Lightweight protocol. Mainly in M2M applications. M2M applications means machine to machine applications. Machine to machine applications. The communication is between machine and machine. When you are communicating with your laptop, it is human to machine communication. Or machine to human communication. When you are output, when you are screening the read, it is machine to human communication. When you are typing something, it is human to machine communication. Whenever, right, the data of the packet moves from router to router. You know routing. Whenever your message moves from, right, say your frame moves from what is it? One place to place or some components. It is machine. Switches to switches. It is a machine. Means it is machine to machine communication. There is a temperature sensor here. I have a device here, processor. I attach with some temperature sensor here. It is uploading the data to the cloud. Cloud in the sense there is a server, there is a storage. This is machine. This is machine to machine communication. Since it is located at some remote place, as I said, forest fire detection system, constraint area. So I will use this protocol. Right. So it follows request response model, communication model, and then above it follows HTTP at application layer and UDP at transmission layer. Means why HTTP means it is following those HTTP commands. It is also using so commands. So it has inherited some characteristics of HTTP. Don't get confused, sir, already HTTP is there. I mean here is it also uses commands like HTTP. But at transport layer it uses UDP. It uses UDP. The next, first, second, third we have MQTT. Full form is message queue telemetry transport. Right, its full form message queue telemetry transport. Another characteristics, lightweight protocol, lightweight messaging protocol. Users publish subscribe communication model, where MQTT is a broker. You have seen the publish subscribe communication model. All those things will come here. It is not necessarily what we should recall and we should ever write. This is happening. In which MQTT is a broker. Again, fourth point is it is constrained environment. It is designed for constrained environment. So we have DDS, another 3 we have, we'll take another 5 or 10 minutes, another 3. In textbook actually there is a reference paper for all these protocols. Reference source. So in that source, when you go to that source, all you will get more details. Why you want to know more details? Any reason? As simple as it is, because when you start developing a project or when you start developing an application, you should know all the features so that you can you can decide which protocol is better for your application, which protocol is better for your application. Academically this is enough. But again, when you enter for developing an application, right, on the industrial side, as or a startup, you need to get into more details. And you should decide which application layer protocol is suitable for your IoT application. Right. Then we have DDS, data distribution service. Not good. I think you people too have, right? They haven't. There is what you say. Then you people, in your people era, Doordarshan is already like outdated, right? Yes. Never had experience with Doordarshan. Good. Doordarshan, television. It's one-to-one translation, you see. Vision, darshan. Nowadays it is OTT. It is era of OTT channels, OTTs, web series. Once you used to be go to theater craze was there. First day, first show, 5 for tickets. Right. Data distribution service. I will use the word D2D. You guess it? You guess? Yes, madam, what is your name? Navya. D2D means? Device to device, very good. It is also for end-to-end device to device communication, machine to machine communication. It is middleware standard. It is middleware standard. Middleware standard. You have hardware, software, you have middleware. Here the program is already burnt. You cannot change it. Are you getting me? Again, question answers. Which communication model? Public subscribe. See, basically understand the matter. Which are using which communication model. That is one thing you should keep in mind. One is full form, another one is which communication model, whether they are suitable for constrained area or not. So almost all are suitable for constrained area environment. Understand the pattern. Cost of quality of service, and it is configurable, it is reliable. Configurable and reliable. These are another important characteristics which separate from the other protocols. How to remember all those things? See, such things, such information comes to your mind. Then what you should do? First you check out all the common features. Then you check out all the features which are different to you. They are unique features. By that you can remember. Then we have XMPP, extensible messaging and presence protocol. XMPP, extensible messaging and presence protocol. For what? For real-time communication, such as streaming. Streaming, you know. Again, this is suitable for gaming, multi-chat, video, audio, video voice calls. How it sends the data? It sends the data in small chunks. Extended messaging and presence protocol. Revise it again and again. What's the time? What's the name? Arvind Swami. What is the time? 12:11. Right. Last one. AMQP. Advanced message queuing protocol. Advanced message queuing protocol. It is used for business messaging. Uses public subscribe model. Also push pull communication model. That is push pull is what? As the name queuing. So we have seen all the protocols which is using different communication models that we have seen. If somebody has correction like this, communication model, tell me this push-pull communication model is used by which protocol? Give me an example of a protocol which uses push-pull communication model. You should say the advanced message giving protocol. Like this, you should be able to keep the in the test people what they do. They won't correct the things. Clear?